Students, today we'll see the probability function connected to continuous random variable. Suppose we have x as a continuous random variable and a function f of x defined on x. So this function is said to be a probability density function of a continuous random variable x if it satisfies the following properties. So the first one is f of x should be greater than or equal to 0 for all the values of x, and when we take up integration of this f of x dx between minus infinity to plus infinity is equal to 1. So if you remember about DRV, the probability function defined, we have used a summation, so which is being replaced by a integration. That is a major difference between both the probability functions. Now mean and variance is given by mean mu is nothing but integration x f of x dx between minus infinity to plus infinity, and variance v is summation integration x minus mu the whole square f of x dx between minus infinity to plus infinity. So let us understand about these quantities by considering this example. Suppose the function a random variable x has the density function f of x, which is given by k x square for the values of x between 0 to 3, and it is 0 elsewhere. So here what we need to consider is the whole of the real line, which is from minus infinity to plus infinity. Now the function only exists or a non-zero quantity in the interval 0 to 3. Elsewhere it is nothing but 0. So for this function, we need to evaluate k and find what are the different probability values. Also, we are going to calculate what is mean and variance for this distribution. Now here what is being given, this f of x is a probability density function. So which implies, according to here the second condition, if you take the integration between minus infinity to plus infinity, the value is equal to 1. So if we apply this, we'll get it as, so minus infinity to plus infinity, you can just take it as minus infinity to 0 plus 0 to 3 plus 3 to infinity. Now here for all these intervals, only for 0 to 3 the function exists. That is, for 0 to 3 the function is what? Defined as kx square dx is equal to 1. We have just substituted over here. So k, take it out, remaining x square, if you integrate x cube by 3 between the limits 0 to, it is from 0 to 3, so this is equal to 1. Now k by 3 out, then this is going to be 3 cube minus 0 cube. So here one of the 3 gets cancelled, 3 square means 9. Take this 9 here, it comes in the denominator, so the value of k here is 1 by 9. Now next probability value. So this is like probability of x less than or equal to 1. That means you have to take 1 is nothing but the upper limit. Now the lower limit for a real line is nothing but minus infinity. So this is going to be only upper limit is mentioned, so it is going to be 1. No lower limit means it is minus infinity of f of x dx. Now here f of x is defined only between 0 to 3, otherwise it is 0. So here the upper limit is 3, but lower limit it has to start from 0. So this minus infinity converts to now that is minus infinity to 0 plus 0 to 1. So then what is the function here? Kx square, and the value of k is 1 by 9, so that it is x square by 9. Take out 1 by 9, remaining x square integral is x cube by 3. When you substitute the limit and simplify, the answer is 1 by 27. Now next, when it is probability of x between 1 and 2. So that means 1 is the lower limit and 2 is the upper limit. Now here in this continuous, it is not much considered if equal to is there or no. That becomes the limit. Okay, so this is 1 to 2. Again the function is now x square by 9. So that when you integrate you will get the value as 7 by 27. So next probability is x greater than 2. That means here x is greater than 2. So you should start from 2. What is the end value there for the real line? It is infinity. But our function exists when the upper limit is just 3. So that here we are going to take it as This lower limit is 2, but upper limit it is still 3, because from 3 to infinity the function is 0 only. So that now if we substitute, it is again x square by 9, integrate, substitute the limit, the answer is 19 by 27. Now mean mu in this case is x into f of x dx between minus infinity to plus infinity. So again here the value is non-zero only between 0 to 3. So f of x is x square by 9. We are writing this x as it is. So x into x square x cube, whose integral is x raised to 4 divided by 4. 1 by 9 is out. If you substitute the limit and simplify, the answer is 9 by 4. Similarly, variance is given by x minus mu the whole square f of x. Again this f of x exists or non-zero between 0 to 3. So x minus, what is the value of mu? 9 by 4 the whole square, and f of x is x square by 9. Now just expand this using a minus b the whole square, a square plus b square minus 2ab. Then we are keeping this x square as it is. 1 by 9 is outside. Now 1 by 9 is out. Now take this x square to each of the term, then integrate it. Integration of x raised to 4, x raised to 5 by 5, then x square is x cube by 3, x raised to 3 is x raised to 4 by 4. Substitute the limits. Now you can clearly observe for the lower limit, when x is 0, the answer is 0 because all terms contains x. Now for the upper limit, when you substitute, simplify, variance is 0.3375. Now see, in the similar way you can solve the next problem. Here it is kx cube, which is where x is from 0 to 1 and 0 elsewhere. Now we can even calculate the different probability values. We have one more different problem over here in this category. So here just take this problem. The probability density function of a continuous random variable is given by f of x equal to y naught e raised to minus modulus of x. X between minus 10 to infinity. We need to find y naught, mean and variance. Now here what is being given, that this function f of x is a PDF. So we have a condition that if you take the integration of this f of x between minus infinity to plus infinity, the value is equal to 1. If you use it, then we'll get it as y naught e raised to minus modulus of x. Now limits are minus 10 to infinity. Now take out this y naught and again divide this minus 10 to infinity as negative and positive interval. So this is minus 10 to 0 plus 0 to infinity. Now if we integrate this e raised to x, it is e raised to x, and integration of e raised to minus x is minus e raised to minus x. Now when we simplify and all, we'll get the value as 1 upon 2, because e raised to minus 10 is very nearer to 0. Now for this, so y naught is nothing but 1 by 2. So let us calculate mean and variance. Mean is x f of x, integration of this between minus infinity to plus infinity dx. Now x as it is, f of x is y naught, and y naught value is 1 by 2, then e raised to minus mod of x. Now the value of this is 0, because if you take only this function, it is going to be an odd function. So we know that whenever a function is odd, the integral of this category is going to be 0. Now if you want to just check for even and odd nature, you can just take the function as this quantity given in the that is integrand function is f of x, and if you replace your x by minus x and check with the thing, we'll get it as minus f of x, so that the function here is nothing but odd, so the value is going to be 0. Next, variance v is given by this definition. Let us simplify. Now mu is 0 here. So this is x square f of x. Now again f of x is y naught. Y naught is 1 by 2. Y naught is 1 by 2, then e raised to minus modulus of x. Now this is now minus infinity to plus infinity. Now if you see this function x square f of x, this is going to be a even function. So we can write it as 2 times 0 to infinity. And if we simplify, and write it. This is x square e raised to minus x, because 0 to infinity is a positive interval. So modulus of x is plus x, so that this outside minus remains the same. So this is x square e raised to minus x between 0 to infinity. Now if we integrate it by generalized rule of integration by parts, we'll get it as keep x square as it is, integrate the next function. So it is e raised to minus x divided by minus 1, change the sign minus. So what you have kept as it is, differentiate, it is 2x, then integration of this e raised to minus x, then minus 1 into minus 1 is plus 1. Change the sign again. So this is plus, differentiation of 2x is 2, e raised to minus x divided by, that is integration of this quantity is e raised to minus x divided by minus 1 between the limits 0 to infinity. Now here when we substitute x as infinity, e raised to minus infinity is 0. So that we'll get the quantity as here 0 for the first two terms. For the last term it is 2 into, if we substitute the upper limit, e raised to minus infinity is 0 minus x is 0, e raised to 0 is 1. So the value comes out to be variance as 2. Thank you.